All right, so, well, we did 4 power rules, right? Multiplying powers, dividing powers, power of a power, and then the 4th rule, the expanded power rule. Now, again, we may have to use those for the next 2 rules, except for the, well, only maybe on the next, the 6th one. The 5th one, like I said, is probably the easiest one of all of them, and that's where we look at zero exponents. All right, so with 0 exponents, you have something like this, x, so it doesn't matter what your base is, to the power of 0. And here's the best part is no matter what the base is, if you have an exponent with a 0, the answer is 1. So if you could have something like, let's see here, I got a bunch of different scenarios. I don't know, we could have a 3 to the power of 0. We could have a negative base, like -4 to the power of 0. We could have a massive number, like, I don't know, 3,187,000 to the power of 0. We could have a fraction for a base, so like 1/5 to the power of 0. We could have like a symbol, pi, to the power of 0, which is actually a number. Or we could have variables in brackets, whoops, like d times o times g to the power of 0. Just like we have x times y, we could have d times o times g. And like I said here, no matter what the base is, whether it's a normal positive number, a negative number, a really big number, a fraction, a symbol that actually is a number 2, or we do have symbols that don't have a numerical value, the answer is 1, 1, 1, 1, all the way across the board. So no matter what, if you have an exponent of 0, the answer is always 1. That's the easiest rule. You don't even have to show any work, which is great, right? I know for some of you don't like showing work. All right, so that's our 5th rule. Now we get to the tough one. So we're doing the easiest one and the tough one this class. So there's the easy one, it's out of the way. So now we get to number 6, our last power rule. And again, we might have to use other rules that we've already done, the first 5, when we do have the 6th one. And what we're dealing with the 6th one is we're looking at negative exponents. All right, so there's a couple ways this can look. All right, so first off, just normally, we have x to the power of -a. So there we go. We got our base, and there's our negative exponent. Now, the key for us with the negative exponents is to make it positive, because we have all these other rules, these 5 other rules, that we can apply if our exponent is positive. And to make that happen, what we do is we take what's called the reciprocal of the base, or as a lot of people like to say, we flip it, we turn it upside down or flip it. So instead of an x, I flip it, it would be 1/x. So we flip the base, and then we can just simply change the exponent to a positive. All right, that could look a different way. For instance, if you had a fraction, say that 1/x to the power of -a. Again, if I flip the 1/x, it would be x over 1, or x divided by 1. Anything divided by 1 is just itself. And so in this case, I flip it, so 1/x would be just become x, and again, I change the exponent to a positive. So that's how we deal with negative exponents. We make it a positive exponent by flipping the base, and then again, we can apply all the other rules to help us out in completing the questions. All right, to simplify things. So for example, A, we have 4 to the power of -2. All right, now I want to find out what 4 to the power of -2 is. So it's a lot like our first definition here. And so again, what I'm going to do is flip the base. So instead of a 4, because I'm going to write 1/4. And again, it's because every number really can be written as a fraction. We just put a 1 in the denominator because, again, anything divided by 1 is just itself. Now, again, I'm going to change that exponent to a positive. But now, here's where rule number 4 comes into play, our expanded power rule. We have two things in the brackets. We can apply the exponent to both the numerator, so I have 1 squared, and the denominator, so I have 4 squared. And then I can further figure that out. Well, 1 times 1 is 1, and my denominator 4 squared is going to become a 16. And so we get 1/16. So that's something you need to be able to do for the tests and quizzes, is not just type this into your calculator and get a decimal. I will want a rational or a fraction. All right, B, let's try another one of those guys. 2 to the negative 5. All right, so again, I'm change the exponent to a positive. That's how I'm going to deal with this. So I flip it. So instead of 2, I'm going to have a 1 over 2. Change my exponent to a positive. And again, rule number 4 coming into play. Going to apply that exponent to both the numerator and the denominator. And it should be a power rule, but it's not. But 1 to the power of anything is just 1, because 1 to the power of 5 is 1 times 1 times 1 times 1, which is 1. But 2 to the power of 5, it's another story. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 again is 32. And so my final answer is 1 over 32. All right, C. See, we switch it up a bit here. Negative 7 to the power of negative 3. So now we got a negative base and a negative exponent. But again, I want to get rid of that negative exponent, so I'm going to flip the base and have my exponent turn to positive. So I'm going to have 1 over negative 7 to the power of 3. Again, I'm going to apply that exponent to both the numerator and the denominator. All right, and then what we get here is, well, again, 1 cubed, 1 times 1 times 1, that's a 1. But now we got the denominator, negative 7 times negative 7 is a positive 49, times another negative 7, though, that's a big number here. It's actually going to be negative 343. There we go. So again, I had to use my calculator for that one. See the negative sign there in the denominator? It's not wrong, but typically when you have a negative sign, you can either put it in the middle or on the top. So it would be negative 1 over 343. Again, it's not wrong, but it's like those people who, to ask you, when you ask what's the score of the soccer game, and they say, my team lost 2-3. Is it wrong? No, it's not, but it just sounds weird. Usually you say they lost 3-2. Same idea with the fraction. Let's see. D. Again, try another one of those. We got negative 8 to the power of negative 2. So again, I'm going to do the same thing I've done before. I'm going to flip my base and change my exponent to positive. All right, and again, applying the exponent to both the numerator and the denominator. Again, 1 squared, 1. Negative 8 squared, so that's a negative times a negative. I know that's tricked a few people up in our last couple of units, but you have a negative times a negative, you end up with a positive, and so our final answer is 1 over 64. All right, I'm going to do a couple different, switch it up now. So we kind of focus on this. I'm going to focus on this rule here. When you have a fraction for a base, because these are all whole numbers, both positive and negative. So let's try when we have a fraction for a base. All right, so for example, let's see here, we have, like I said, we're going to do a different one here, fraction per base. So A, we have 4/3 to the power of negative 2. All right, so we're kind of focused on this now. A lot of people find that easier because you have a numerator and a denominator. It's obvious. So you can flip the base again and apply the exponents, or change exponents, sorry, to a positive. So instead of 4/3, I flip my base, I got 3/4. Again, I change my exponent to a positive. All right, and again, rule number 4, applying to the exponent to both the numerator and the denominator. And let's see here. So I have a 3 squared and a 4 squared. Well, 3 times 3 is 9, and 4 squared is a 16. There we go. So we get 9/16. B. Let's see, try another one of those. Let's see here. So 2/7 to the power of, let's see here, -3. There we go. All right, so again, same thing I've been doing with negative exponents, flipping the base, change my exponent to a positive here. And so we end up with, instead of 2/7, we're going to have 7/2. Again, there's my exponent changed to a positive. And let's see here, apply the exponent to both the 7 and the 2. 7 to the power 3. I think we had something like that. That was a big number. 7 times 7 times 7, 343. And, well, 2 cubed, 2 times 2 times 2. That is an 8. So again, there's an example now when we have a basis of fraction. All right, now, last example. Let's see here. A little something different. We're going to just use our definition just in a slightly different way. All right, so we get something like this where it says find x. This is kind of a different example. Find x. And we get something like this where we have x to the -3 equals 1/64. And I want to solve for x. Now, again, what I want to do is get rid of this negative exponent by using my definition here. So I am going to change this exponent to a negative, or sorry, to a positive by flipping the base. So I have 1/x and change my exponent to a positive. All right, so I have, all I did there was change my exponent to a positive again by using my definition. Now I'm going to apply that exponent. I guess I'm running out of room here. I'm going to apply that exponent again, rule number 4, to both the numerator and the denominator. All right, now 1 cubed, 1 times 1 times 1. It's just 1. So I can really just get rid of that 3. Now, see, we want to solve for x. Now we're matching things up in our equation. That means x cubed is equal to 64. So now I got to kind of trial and error and look at what number times itself 3 times would give me 64. Try 2, 2 times 2 times 2, that's an 8. 3, 3 times 3 is 9, times 3 is 27, not good enough. 4, 4 times 4 is 16, times 4 is 64. And so therefore, my x value is equal to 4. And there we go, that's how we solve for x. Again, the key with a negative exponent is using our rules here to switch our negative exponent to a positive exponent, because then we again have all these different rules that we can apply and use. Without doing that, you're stuck. All right. So again, there's our 6 power rules